Hello everyone, my name is Akshay J, and together with my friend Vinay, we have done the IoT home automation project, which was part of our Emertxe internship. We are currently doing mechanical engineering, and we are in our final year, and we're doing this course at Assistant College of Engineering, Chennai. So basically, in this video, we'll be talking about the introduction of home automation and what it exactly means, the features of C programming that has been taught throughout this internship. We'll also be talking about what IoT is and what embedded systems are. Later on, we'll see about the objectives of the project requirements, and finally, I'll show you a demonstration of the project I did and how it works. So first, coming on to the introduction, what is home automation? So home automation is basically converting all the devices and appliances that are present at your house and making it electronic so that it can be easily accessed by the press of a button in your phone. It makes your life more convenient and easy, at the same time also secure. Home automation is a network of hardware, software, as well as electronic devices that are integrated into one, um, and combined with the devices at your house through the internet. So it has various applications, like it is used to, for example, turning on off the lights, can be used to turn off the heater, turn on the cooler, can be also used to lock certain doors of your house, and many more. So let's look at the three main elements of a home automation system. The first one is sensors. So sensors are basically it allows you to monitor the differences that you can feel or see in your devices, and at the same time, it also helps you to adjust those settings according to your preference. These changes can be changes in sunlight, in temperature, in motion detection, various others. Now, the second element is a controller. So, controller basically is a device that could be a computer or your phone that helps you to send and receive messages about the status of the value that you're measuring. So that value could be the temperature, it could be the amount of light, it could be the distance between two objects, and etc. So the controller helps you to send and receive messages. Third one is the actuator. So the actuator can be switches, motors, valves, that helps you to physically control the situation and adjust those settings. So they are programmed to be activated by a remote command from a controller. That could be your phone or your computer. So now let's go into the C programming section. So first, there are a lot of lot of things that were taught during this internship. So the few that are stated here are conditional statements, operators, arrays and pointers, functions, storage classes, and preprocessor headings. So let's look at few of these in detail. First is a conditional statement. So a conditional statement is basically to produce an output based on a certain condition that you're given. So within that conditional statement, there are many types like the if statements, the for loops, while loops, switch cases, and etc. So let's take a look at one of these statements. First is the if. So one of the examples is the if else statement. The if else statement basically takes an input according to a condition, and then prints the output accordingly. So if you look at the if you look at the diagram given here, first the condition is taken, and if the condition is true, the if code is executed, and if the condition is false, the else code is executed, and then the program stops. So let's look at a simple example. First here, I've given an input to a variable as 11. Now my condition is if the variable is less than 10, print it is not a two-digit number, and if it is greater than 10, you print it is a two-digit number. So here, as you can see, the number that is inserted is 11, and hence and since it satisfies the condition, and since sorry, it does not satisfy the condition, the output goes to this else statement, which is it is a two-digit number. So uh, that is how this if else statement works. Now let's look at the operators. So there are a lot of operators present in C programming. Few of them are arithmetic, logical, relational, and assignment operators. So if you look in this table here, there are a lot of symbols given to each C programming operator. Now there are two types of operators here, unary operators and binary operators. So unary operators basically take a single, it only requires a single variable and it can produce an output, right? Whereas a binary operator requires two inputs to produce an output, where where the binary operator can be either addition, subtraction, or checking for if it's greater than another value, uh, not equal to another value, etc. Whereas the unary operator is basically trying to increment or decrement a particular variable. So next is arrays. So arrays are basically used to store a lot of values of the same type in a single in a in a single variable. So although it cannot store data types of different it cannot store values of different data types, it is still a very useful tool. Next come the pointers. So pointers are used to store the memory address of the variable and not the data itself. So it'll help you to access the data much quicker rather than if you don't know what the memory address is. That's why pointers are much more efficient in that. Now let's talk about what IoT is. So IoT stands for Internet of Things, and it combines the physical objects and sensors, softwares, and other technologies so that so that it can be used to transfer data from one system to another. Over the past few years, there have been a lot of technological advances in IoT, and I feel in coming years it's going to increase even more, and it, it it's going to make uh, the lives of people very easier. So the another major advantage of IoT is that it requires minimal human intervention. So physical data can be easily transferred between two objects and two devices very easily without any human intervention. And this is how the physical world is meets the digital world, and that's how they cooperate together. Let's look at the key building blocks of IoT. So there are four major building blocks. First is obviously the device. The next thing that is required is the network. So without proper network, it's difficult for two devices to communicate with each other, and hence it is very important. The middleware is the pre-processing. That's where the actual it's basically the heart of the IoT, where the functions and the processes take place. The applications can be the sensors, the actuators, and all that are required to make it an IoT device, make it a digital device is what is comes an application. So this is the key building blocks of IoT. Now let's look at the embedded systems. So an embedded system is a system that consists of a software, computer hardware, which are used for various applications. And it also it can either be a small system or a large combinational system. It's basically a microcontroller which is used to perform a specific task. So an embedded system consists of major three components. First is the hardware. The hardware is the device that you're going to physically connect this embedded system to, and the one that you want to gain you want the output to be produced. The second one is application software. Application software basically allows the user to modify the code as they wish. according to how they want the output to be produced. And then the next is the RTOS. It stands for Real Time Operating System. It acts as an interface between this hardware and software, so that it makes sure that the there is no disconnection between the two, and it's scheduled for proper running. So all these embedded systems are used nowadays in EV vehicles as well for testing and trying, so that they make sure that there's good R&D that has gone. There's good R&D search that can be done using embedded systems. So some of the examples of embedded systems, as I said, one is automobiles, where you want to convert it to electric vehicles. Even mobile phones are consist of many embedded systems that include cameras and microphones. Industrial machines are also being automated nowadays, so that monitoring and specific tasks to do. Even the medical equipments are consists of sensors and control mechanisms, so that 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 will make the job of doctors and nurses much easier. So, okay, now coming on to the objective. Now coming on to the project. So the three main objectives uh, that were required in this project. The first is the garden controlling the garden light. Second was the temperature control, and third was the water level control. So let's look at the three in detail. The first is garden light control. So here our task was to basically control the garden lights depending upon the amount of sunlight that is present in the surrounding space. So there's less sunlight, the garden lights are activated and switched on, whereas in the morning when there's enough sunlight, the garden lights are switched off automatically. So what we did here, we used the Pixel Lab software, where we use the LDR sensor as the input and LED bulbs as the output. So LDRs are basically light sensing devices. It's also known as photoresistors. So it is a resistor whose resistance changes depending upon the amount of light that is present on it. Now, uh, as the resistance increases, which means there's not much sunlight available, and hence the LEDs have the garden light has to be switched on. Whereas if the resistance is less, that means there's not much there's a lot of sunlight available on it, and hence the LED switched off. Then next, coming on to the temperature control system. So here we aim to control the temperature of the room depending upon whether it's too hot or whether it's too cold. So here we have taken a heater and a cooler, which are automated and can be done manually as well, where we switch on the heater if it is too cold and switch on the cooler if it is too hot. So in the diagram, as you can see in this diagram, the temperature system provides the temperature value to the Arduino Uno board, which then sends it to the Blink IoT app. Now, since we can see how hot or how cold the room temperature is, the heater control or the cooler control are activated respectively, and then that is sent to the temperature system. And the Arduino Uno boards also send notifications to the app, as well as they display it on the CLCD, so that it makes sure that the user knows what is happening behind the scenes. Here also we use the sensor we use is the LM35 sensor. So the LM35 sensor produces an output voltage which is linearly proportional to the temperature. So that value is basically displayed on the Blink IoT app, and then the heater and cooler can be turned off respectively. Next is the water level control. So the amount of water in a tank, let's say, can be controlled by automation again. So here what we use is a null emulator to set up a serial communication between the PIC lab and the serial tank. So the process is similar to the temperature control, where a microprocessor is programmed so as to turn off the inlet valve, the tank, so that to turn off the inlet valve, the tank is filled up, and turn on the inlet valve, turn on the valve if it falls below 2000 liters, so that there's a constant amount of water that is present in the tank. And all of these values again are whether the control is on or off, the amount of volume is all displayed in the CLCD. Notifications are also sent to our Blink IoT app. So this was our presentation. Now let's go to the project demonstration. First, I'll talk about the code that we wrote first. So here, first we insert our authentication name, authentication token, device name, template ID based on the app we've created, so that we can link the phone with the Ping SimLab software. Then we have defined all the libraries and the header files that are required. Coming to this Blinklight program, Blinklight function, where we on the inlet valve based on the volume that is present in the tank, and we also display it. We also print the print this inflow on, so that we are aware of what is going on. At the same time, if the water is overflown, then we can also then the valve is closed, and you this notification is again displayed in the CLCD. Similar to the outlet valve, similar function, the outlet flow on and outlet flow off. So that was this program was for the water level tank. Now you're coming to the temperature control system. Again, similar to what we did previously, we basically, if the temperature is beyond a certain value, like 35 degrees Celsius, the cooler is turned on, and if it is goes below a certain value, the cooler is turned off. And same with the heater. If it's too cold, then the heater is turned on, and if it becomes too hot, then the heater is automatically turned off. And this is that function where called handle temp, where we read the temperature, and if it's greater than 35 degrees Celsius, we off it, and it offs automatically. This was for the water level tank, where if the tank volume is less than 2000, you on the flow, you on the inlet valve, so that the water gets starts increasing in the tank. And similarly, if the tank volume becomes equal to 3000, then you off the flow, and you turn off the inlet valve. Right? And then a function called void setup, where we initialize all the functions here, and void loop is used to put the parameters and the syntaxes of all the functions that we defined here previously. So that was void loop. Then we have the LDR.cpp, where we this was for the garden light control. So you control the brightness of the brightness of the LED lights that are present in that Ping SimLab software, which I'll show you in a few minutes. And here again, you're just defining the functions, and these are basically pins. These are basically the pin numbers, the pin numbers that are there in the Arduino Uno board. So those have been defined here. Similarly here as well, all the pin numbers and the pin values have been defined here. And then you come to the serial tank, where again you assign the volume as well, and try and find till what level, till what volume has your till what level has your tank been filled till, and then you read all those values, and according to the level that it is currently, you disable or enable the inlet and outlet valves. Again, here you're just initializing, defining all your functions. The temperature system, again, it's similar to the tank, where based on the temperature that you have read, you either on or off the cooler. So you have cooler control, heater control, and then you initialize whether the heater, if it's too cold, then you want the heater, which is already done in this segment. So this is what this program does. Here again, you define the pins for the heater and cooler. You define all the functions according to necessity. So now, okay, now let's look at the project demonstration. So here you have the Pixim Lab. This is the Pixim Lab software, and over here you have the LDR and the LEDs. Now, as you can see, if I reduce the resistance, which means there's a lot of sunlight outside, and hence the LED switched off. Now, as I keep increasing the resistance, you see it starts to get brighter and brighter, and as the resistance is maximum, the LED starts brightening, which means that there's no sunlight now and it's full dark, so the garden light has to be on, should be on. So this is the garden light control. Now let's look at the water control and the water level tank and the temperature control system. Now as you can see here in this image, you have two tabs here, tab 1 and tab 2. So tab 1 is basically our temperature system, and tab 2 is our water level control. Now when you look at tab 1, when you on the heater, when you on the cooler, sorry, you see the fan starts radiating and hence it provides cool air. Now when you off it and on the heater, you can see on the CLCD screen that the amount starts increasing, the temperature starts increasing, and as it reaches 35, there's a notification which says temperature is above 35, so you're turning off the heater and the heater gets automatically turned off, right? And there's also, it also starts printing here. Even when you, and if you want, you can even manually on and off it. Even the cooler, when you're on the cooler, it says, it also provides like a message on the CLCD screen. So this is the water cooler. This is the temperature system. This is the temperature system control. Now let's look at the water level tank. Now as you can see, this is the water level tank, and when you, now basically the tank is filled with water. Now when you on the outlet valve, you can see that the water starts reducing. You can even see here the volume keeps decreasing until it reaches 2000, and when it reaches 2000, you can see the notification. It says water level less than 2000, turning on the inlet valve. So it turns on the inlet valve and the water starts increasing again until it reaches 3000, where the water level again, you see the notification, it will say the water volume is full, so you're turning off the inlet valve. So now the inlet valve is turned off and no water is allowed to flow into the tank. So this is our project. Thank you so much for taking your time and listening to us.